Hello and welcome to this video today in which I'm going to discuss counting to a googol. A googol is 1 followed by 100 zeros, which is equivalent to 10 billion, 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 trillion, 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 trillion. So, how long would it take to count to a googol? Well, let's assume you're counting at 4 numbers per second. So, basically it would be something along the lines of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, okay. You get the point, except I missed the 16 there. But basically, you'd be counting at a pretty fast rate, actually. Um, but even at this rate, in order to count to a million, it would still take you 2 days, 21 hours, and 27 minutes, assuming that you don't stop. Obviously, this is all hypothetical. Um, but in order to reach 10 billion, which of course is the first step of the extended version of Google of 10 billion, 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 trillion, 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 trillion. In order to reach 10 billion, count to 10 billion, it would take you at a rate of 4 numbers per second, 79 years and 2 months. Well, a little bit over that. So it would be into autumn 2094 or 2094. So it would be in the late 21st century, and you would have counted 10 to 10 billion. But how long would it take to count to say 10 billion billion, which is actually 10 quintillion? So to count to 10 quintillion, it would take you a massive 79.2 billion years, which of course if it's a billion times 10 billion, then it's a billion times 79.2 years. So 79.2 billion years later, and you've counted to 10 quintillion. So you've made some progress by that point, which is 10 billion billion or 10 quintillion is 1 followed by 19 zeros. But you have to remember, even though 1 followed by 19 zeros, you think, oh, well, that's not too far away from 1 followed by 100 zeros. It's actually immensely far off, because if you go from 1 followed by 19 zeros up to 1 followed by 20 zeros, you're scaling it up by a magnitude of 10. In other words, 1 followed by 20 zeros has 10 times as many numbers in it as 1 followed by... Sorry, no, you have to count 1 followed by 19 zeros. You have to count that 10 times in order to reach 1 followed by 20 zeros. So you're scaling it up by a magnitude of 10 each time, and you have to do that all the way up to 1 followed by 100 zeros. So we have a long way to go. So 10 billion billion, or 10 quintillion. So in other words, you'd be 79.2 billion years into the future, and if you've counted to 10 billion billion. By this time, um, the sun would probably be a white dwarf, and yeah, we're not even getting started. Um, in order to count to 10 billion billion, as I said, it would be several times the length of the history of the entire universe that has existed so far. But in order to reach 10 billion billion billion, which is 10 nonillion, so in order to reach 10 nonillion, and keeping in mind, in order to reach 10 quintillion, which is 10 billion billion, you'd have to be counting for of times the length of the history of the entire universe, 79.2 billion years actually. You'd have to be counting for a billion times that, which adds up to 5,700 million times the length of the entire universe. So in other words, after 5.7 billion times the history of the universe, and you would have reached 10 billion billion billion. So basically, to simplify this, let's use the term cosmic year. So a cosmic year is 13.8 billion years, which is the amount of time that the universe has lasted for so far. So after a cosmic year has passed, that's, well, obviously a very, 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 very long time. You'd have to do that 5.7 billion times. So in other words, the number of cosmic years that would have to pass, the number of cosmic years that would have to pass would be nearly half the amount of, equivalent to half the amount of real years that the universe lasted for, which is obviously a very large amount. So let's assume that 5.7 billion 5.7 billion cosmic years, which each of those cosmic years lasts 13.8 billion years, we reach another scale, mega cosmic years. We would now need roughly a trillion mega cosmic years to reach 10 billion trillion. So of course, within a trillion mega cosmic years, we'd have 57 billion cosmic years, and in each of those cosmic years, we would have 13.8 billion real years. So 13.8 billion real years, 57 billion of those, and then it equals to 1 mega cosmic year, and then a trillion of those. So that is 10 billion trillion, which in itself is equal to 1 followed by, I think, 40 zeros. And yet we have to scale that up times 10 another 60 times before we'd even get to a googol. So let's keep going. After a trillion megacosmic years, of which each megacosmic years comprises 57 billion cosmic years, which each of those cosmic years comprises 13.8 billion years. So after a trillion of those megacosmic years, we've reached a billion trillion. Yeah. So we've reached a billion trillion. So let's assume a trillion megacosmic years is equal to an ultra cosmic year. I just have to come up with names as we go along for this. We need a trillion of those to reach the next level, and that would then be the equivalent to 10 billion trillion. So then you do it again a trillion times on the next level of I don't know, like you could say we've been on to ultra cosmic years, so we'd have a trillion ultra cosmic years equal to a mega ultra year, or whatever you want to call it, and that would be 10 billion trillion, I think. And then you go up then another scale and do it all again with hyper ultra years, and do it again with extreme hyper ultra years, and then finally do it one more time of a trillion ultimate years, is what you call it. So in other words, a trillion ultimate years will comprise a trillion extreme hyper ultra years, which will comprise a trillion hyper ultra years, which will comprise a trillion mega ultra years, which would comprise a trillion ultra cosmic years, which would comprise a trillion mega cosmic years, which will comprise 57 billion cosmic years, which in itself will comprise of 13.8 billion real years. That's a very long time, counting at 4 words per second, and you'd finally have counted to a googol. So, in other words, in order to count to 10 billion trillion, which is a very long time, you would need, first of all, 13.8 billion years. You need the history of the universe. You'd have to live through the history of the universe. I said 57 billion, I think I meant to say 5.7 billion, sorry. 5.7 billion cosmic years. So in other words, live through the entire history of the universe so far, and then do it again and again 5.7 billion times. So in other words, where it's like basically saying the universe lives half the time its contents have in respect to a higher universe or something like that. You need a trillion, you need 57 billion cosmic years, and then you need a trillion of those 57 billion cosmic years. Then you need a trillion of those mega cosmic years. Then you need a trillion of those ultra cosmic years. Then you need a trillion of those mega ultra years. Then you need a trillion of those hyper ultra years. Then you need a trillion of those extreme hyper ultra years. And then you need a trillion of those ultimate years. These are just made up names, obviously. And after all that amount of time has passed, you'd have counted to a googol. But to put that into perspective, a googolplex is basically, it's so big that counting at 4 numbers per second overall, the amount of time it took you to count to a googol, which is obviously very big, as you know, the amount of time that would take you to count to a googol, scaling that up, you would have counted to as much the total number of googolplex by the time you reach a googol in all those 1 trillion ultimate years as you would have counted after 1 second of counting to a googol. So in other words, on a matter of scale, a googol is like the number 4 in respect to a googolplex. It's very, very big. That's it for this video. Next time, goodbye.